Did you know that the Sun accounts for about 99.86% of the total mass of the solar system? Its immense gravity holds the solar system together, keeping planets, asteroids, comets, and other objects in their orbits. The Sun's mass is so dominant that it can influence the trajectories of comets millions of kilometers away. This central role of the Sun in our solar system is a testament to its power and importance in shaping the dynamics and evolution of the celestial bodies that orbit around it. Understanding the Sun's influence helps astronomers predict the movements of objects within the solar system and study the effects of solar activity on Earth. Did you know that the sunspot cycle, also known as the solar cycle, significantly affects space weather and can even influence climate patterns on Earth? The solar cycle is an approximately 11-year cycle during which the Sun's magnetic field flips and returns to its original state, leading to a fluctuation in the number of sunspots. During solar maximum, the Sun exhibits more sunspots in solar activity, such as solar flares and coronal mass ejections, which can disrupt satellite communications and power grids on Earth. Conversely, during solar minimum, solar activity decreases. Understanding the solar cycle is crucial for predicting space weather events and mitigating their impact on technology and climate on Earth. Did you know that the solar system is moving through the Milky Way galaxy at an astonishing speed of approximately 828,000 kilometers per hour, about 515,000 miles per hour? This movement is part of our galaxy's rotation around its central point. The solar system is located in the Orion Arm, a spiral arm that extends from the Milky Way center. As it travels, the solar system is also bobbing up and down through the galactic plane, completing this vertical oscillation approximately every 70 million years. This motion through the galaxy means that the scenery of the night sky changes over millions of years, providing a dynamic backdrop to our existence within the cosmos. Did you know that our solar system is located in a galaxy known as the Milky Way, which is just one of billions of galaxies in the universe? The Milky Way is a barred spiral galaxy, featuring a central bar-shaped structure composed of stars, with spiral arms extending outwards. Our solar system resides in one of these spiral arms, known as the Orion Arm, which is located about 27,000 light-years from the galactic center. The entire Milky Way galaxy is estimated to contain 100 to 400 billion stars and at least that many planets. Exploring our position within the Milky Way helps astronomers understand the structure and scale of our galaxy and its place in the broader universe. Did you know about K2-18b, an exoplanet located in the habitable zone of its star within the constellation Leo? Discovered by the Kepler spacecraft, K2-18b is classified as a super-Earth, meaning it has a mass and size larger than Earth but smaller than the ice giants Uranus and Neptune. What makes K2-18b particularly intriguing is the discovery of water vapor in its atmosphere, a key ingredient for life as we know it. This exoplanet orbits a red dwarf star and is located about 124 light-years away from Earth. The presence of water vapor, combined with its location in the habitable zone, suggests that K2-18b could have conditions suitable for liquid water, raising the possibility of habitability. Did you know that Jupiter emits more heat than it receives from the Sun? Despite being far from the Sun, Jupiter is a significant source of heat in the solar system. This is because Jupiter generates its own heat through a process called Kelvin-Helmholtz mechanism, where the planet slowly contracts over time, converting gravitational energy into thermal energy. As a result, Jupiter radiates about twice as much energy as it absorbs from the Sun. This internal heat source is responsible for some of the complex atmospheric phenomena observed on Jupiter, including its turbulent storm systems and the rapid movement of cloud bands across its surface. Did you know that there are more stars in the universe than grains of sand on all the Earth's beaches? Astronomers estimate that the observable universe contains about 70 sextillion stars. That's a 7 followed by 22 zeros. This staggering number highlights the vastness of the universe and puts into perspective the sheer scale of the cosmos. Each star is a sun to its own solar system, potentially harboring planets with unique conditions. The possibility of life beyond Earth becomes more conceivable when we consider the incredible number of stars and planets that exist across the universe. This fact about the universe not only expands our understanding, but also fuels our imagination about what lies beyond our own planet. Did you know that the moon Titan orbiting Saturn has an atmosphere denser and thicker than Earth's? Titan is the only moon in our solar system with a substantial atmosphere composed mainly of nitrogen with traces of methane and hydrogen. This thick atmosphere creates a greenhouse effect that allows for complex weather systems, including clouds, rain, and possibly even cryovolcanoes that erupt water ice and ammonia. Titan's surface is hidden beneath its smoggy atmosphere, but data from the Cassini spacecraft suggests it has lakes and rivers of liquid methane and ethane, making it one of the most Earth-like bodies in the solar system, albeit with a much colder environment. Did you know that the planet Neptune experiences some of the fastest winds in the solar system? Winds on Neptune can reach speeds of up to 2,100 kilometers per hour, about 1,300 miles per hour, far exceeding the strength of any storm on Earth. This blue giant, the eighth planet from the Sun, remains a mystery to scientists in many ways. Its extreme weather patterns are thought to be driven by the planet's internal heat, rather than solar energy, given its great distance from the Sun. The discovery of these fierce winds was one of the many surprises uncovered by the Voyager 2 spacecraft during its flyby in 1989, providing valuable insights into the dynamic and varied nature of weather across our solar system. Did you know that Saturn is the only planet in our solar system that is less dense than water? If you could find a bathtub big enough, Saturn would float in it because its average density is about 0.7 grams per cubic centimeter, while water's density is about 1 gram per cubic centimeter. This low density is due to Saturn being composed mostly of hydrogen and helium, similar to a giant gas balloon. Despite its size, being the second largest planet in our solar system, its composition makes it significantly lighter than Earth. This unique characteristic of Saturn provides fascinating insights into the composition and formation of gas giants. Did you know that the Sun is not a solid object, but a massive ball of gas? It's composed mainly of hydrogen and helium, undergoing nuclear fusion in its core. This fusion process releases an enormous amount of energy, which lights up the Sun and provides the warmth necessary for life on Earth. The Sun's surface, known as the photosphere, has a temperature of about 5,500 degrees Celsius, 9,932 degrees Fahrenheit. Despite its gaseous state, the Sun has a differential rotation, meaning its equator rotates faster than its poles. This rotation, along with convection movements inside the Sun, generates a complex magnetic field that affects solar activity, including sunspots and solar flares. Did you know that the light we see from the Sun takes about 8 minutes and 20 seconds to reach Earth? This is because light travels at a speed of approximately 299,792 kilometers per second, 186,282 miles per second. And the average distance between the Sun and Earth is about 149.6 million kilometers, 93 million miles. This phenomenon means that we are always seeing the Sun as it was about 8 minutes ago, not as it is at the exact moment we look up at it. Understanding the speed of light and its implications help scientists measure vast distances across the universe and study celestial objects as they were in the past, providing a fascinating glimpse into the history of the cosmos. Did you know that the planet Jupiter has a faint ring system? Unlike Saturn's prominent rings, Jupiter's rings are composed primarily of dust particles ejected from its moons. This ring system was discovered in 1979 by the Voyager 1 spacecraft. Jupiter's rings are divided into 3 main segments: the halo, main, and gossamer rings. These rings are much fainter than those of Saturn because they're made up of smaller, less reflective material. The existence of Jupiter's rings challenges our understanding of how ring systems are formed and maintained around giant planets, providing valuable insights into the dynamics of our solar system. Did you know that Neptune has a peculiar and still unexplained feature known as the Great Dark Spot? Similar to Jupiter's Great Red Spot, Neptune's Great Dark Spot is a massive storm, but it's darker and appears to be more temporary. First observed by the Voyager 2 spacecraft during its flyby in 1989, this giant storm was about the size of Earth. Intriguingly, when the Hubble Space Telescope looked for the storm again in the early 1990s, it had disappeared, only for a similar spot to appear on another part of the planet later. This phenomenon suggests that Neptune's atmosphere is highly dynamic and subject to rapid changes, a mystery that continues to captivate astronomers. Did you know that Phobos, one of Mars's 2 moons, is slowly spiraling towards the planet? At a rate of about 1.8 meters every 100 years, Phobos is gradually getting closer to Mars and is expected to either crash into the planet or break apart and form a ring around Mars in about 50 million years. This unusual fate is due to tidal forces, which are gravitational interactions between Mars and Phobos. Unlike most moons in the solar system, which are moving away from their planets, Phobos' orbit is decaying. This makes Phobos a subject of intense study, as its eventual disintegration could offer insights into the dynamics of tidal forces and the future evolution of Mars' system. Did you know that Neptune's moon Triton is one of the few geologically active moons in the solar system, featuring geysers that spew nitrogen gas into space? Triton orbits Neptune in a retrograde direction, meaning it moves in the opposite direction of Neptune's rotation. This unique orbit suggests that Triton was not originally part of Neptune's moon system but was captured by Neptune's gravity. Its surface is relatively young and shows evidence of cryovolcanism. Triton's geysers, discovered by the Voyager 2 spacecraft, can shoot material up to 8 kilometers (5 miles) into its thin atmosphere, making it one of the most intriguing celestial bodies in our solar system.